This is a quick video review of problem number 30, section 2.5 from Stewart Calculus, Early Transcendentals, 8th edition. As we look at this function is really the ratio of two continuous functions, and they're going to be continuous where they're both continuous and where the denominator is not zero or undefined in other ways. So let's start by looking at the denominator because it's certainly the source of a lot of problems. So the denominator is this function, square root of 4 minus x squared, and we can rewrite that by factoring it as square root of 2 minus x times 2 plus x. Clearly, we can't use 2 or negative 2 in our original function because that's going to be places where the denominator is equal to 0. So those get thrown out right away. But we got to examine this further because we can't have negative underneath the square root of the denominator in addition to places where it's 0. So where is it negative? To examine that, let's leave this for a second and take a look at the graph and consider the function. Now we're going to put this into a graphing calculator. So that would be right here. The function is already defined, 4 minus x squared. There's two different ways you can look at where 4 minus x squared is positive. The first way is to simply look at the graph. So here's a quick look at my window. The graph looks like this. The graph goes from negative to positive to negative. Well, we want to know where the function is positive, so that's here between negative 2 and 2. Now, sometimes your functions aren't going to be quite so friendly to graph, and if that's the case, you might want to look at them more numerically. If you know where it's equal to 0, say 2 and negative 2, you can test points between the roots and see if the function changes signs. So for us, that would look like this. First, we'll start by making sure that our window settings are correct. So the window settings that I'm interested in are here on the line that says independent. Make sure you set that to ask. So if it's not already set to ask, go there and then press the enter key while the cursor is hovered over ask. Dependent, I like that set to auto. You can see the keystrokes that I used down here. To get to the table then, press the second key, then the graph key, and you can type in some choice values. So these values show me the same thing that the graph is showing me, and that is that the function goes from negative to positive to negative. That means that middle interval between negative 2 and 2 is the only place where the square root function is actually defined. Well, what else do we need to consider in looking at our graph? Trying to figure out where it's continuous. We have to look at the numerator part. The numerator is the tangent function. Tangent of x is sine of x over cosine of x. Again, these are both continuous functions, but you're going to run into problems when the denominator here is 0. So where's the cosine equal to 0? Well, let's think about the graph of the cosine. And in particular, let's think about the cosine function as being defined as the x-coordinate of your points on the unit circle. So that's going to be well defined everywhere, except there's going to be two places where that value is 0. Right up here at pi over 2, and down here at 3 pi over 2, the cosine is going to be equal to 0. Well, in fact, if you keep on going around to 5 pi over 2 or to 7 pi over 2, you're going to find more and more places where that cosine function is 0, hence the tangent's undefined. So here's your general expression. Here's a different form of that general expression. And basically, this is showing you odd numbers. 2 times n plus 1 is a fancy way of saying all the odd numbers. N here has to be an integer. So at values of x like pi over 2, 3 pi over 2, or negative pi over 2, negative 3 pi over 2, etc., that's where your function is going to be undefined. So what's that mean for the graph? Well, In our interval -2 to 2, we only run into 2 of those vertical asymptotes. We run into them right here at pi/2 and here at -pi/2. But what about this space between -2 and -pi/2? Is there anything filling up that? And the answer is yes. If we change our viewing window a little bit, I'm going to pull a little trick here. If you hit the Shift key and then scroll down, you should be able to squish our graph a little bit. You can see that, yeah, there is some function here between -2 and -pi/2, and then again between -pi/2 and pi/2, and finally between -pi/2 and 2. Where the function is defined, it's going to be continuous by the theorems in section 2.5. So where's that exactly? It's right here. Hope that helps with section 2.5, problem number 30.